In electrical systems, color codes are used to identify phase conductors, neutral conductors, and ground conductors. These color codes help electricians and technicians safely work on electrical systems by providing a quick visual reference for identifying different wires. However, it is crucial to remember that color codes can vary by jurisdiction, and it is always necessary to verify the wiring with a voltage tester before beginning any work. Let's review some common color codes for different voltage systems. For a 480 volts, 3-phase system, the standard color code is as follows. Phase 1 is typically brown. Phase 2 is typically orange. Phase 3 is typically yellow. In a 208 volts, 3-phase system, the color code is different. Phase 1 is typically black. Phase 2 is typically red. Phase 3 is typically blue. Moving on to 120 volts single-phase systems, the color codes are as follows. The hot wire, which carries the electrical current, is typically black. The neutral wire, which provides a return path for the current, is typically white. The ground wire, which is used for safety and grounding purposes, is typically green or bare copper. It's important to understand the function of each of these wires. The phase wires, also known as hot wires or line wires, carry the alternating current from the power source to the load. In a 3-phase system, there are 3 phase wires, each carrying a voltage that is 120 degrees out of phase with the others. This arrangement provides a more consistent and efficient power delivery compared to a single-phase system. The neutral wire provides a return path for the current, allowing it to flow back to the source. The neutral wire is typically connected to ground at the service entrance, creating a grounded system. This grounding helps to stabilize the voltage and provide a path for fault current to flow in the event of a short circuit. The ground wire is a safety conductor that provides a low impedance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse, quickly disconnecting the power and preventing electrical shock. The ground wire is typically connected to the equipment grounding system and the grounding electrode system, which provides a connection to the earth. As mentioned earlier, it is important to note that these color codes can vary depending on the specific jurisdiction or application. Some local electrical codes may have different requirements for color coding. It is always a good practice to consult the local electrical codes and regulations to ensure compliance. In addition to checking local codes, it is absolutely essential to use a voltage tester to verify the wiring before working on any electrical system. A voltage tester can confirm the presence of voltage on a wire and help to identify the different conductors. There are several types of voltage testers available, including non-contact voltage testers, digital multimeters, and analog multimeters. A non-contact voltage tester can detect the presence of voltage without making direct contact with the wire. This type of tester is useful for quickly checking if a wire is energized. A digital multimeter can measure voltage, current, and resistance with a high degree of accuracy. It can also be used to perform continuity tests and diode tests. An analog multimeter uses a needle and scale to display the measurements. It is less accurate than a digital multimeter, but it can be useful for detecting rapidly changing voltages. When using a voltage tester, it is important to follow the manufacturer's instructions carefully. Make sure the tester is in good working condition and that the batteries are charged. Always wear appropriate personal protective equipment such as safety glasses and insulated gloves. When testing a wire, first make sure the circuit is de-energized by turning off the circuit breaker or removing the fuse. Then use the voltage tester to verify that there is no voltage present on the wire. If the tester indicates that voltage is present, do not proceed with the work until the circuit has been properly de-energized. In addition to color codes and voltage testers, there are other important safety precautions to follow when working with electrical systems. Always work in a dry environment and avoid contact with water. Never work on energized circuits unless you are properly trained and equipped to do so. Use insulated tools and equipment to prevent electrical shock. Wear appropriate personal protective equipment such as safety glasses, insulated gloves, and arc-rated clothing. If you are not comfortable working with electrical systems, it is best to call a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. To summarize, the standard color codes for electrical systems are as follows. For 480 volts, 3-phase, phase 1 is brown, phase 2 is orange, and phase 3 is yellow. For 208 volts, 3-phase, phase 1 is black, phase 2 is red, and phase 3 is blue. For 120 volts, single phase, the hot wire is black, the neutral wire is white, and the ground wire is green or bare copper. Always check local electrical codes for specific requirements and use a voltage tester to verify the wiring before working on any electrical system. Remember to prioritize safety and take all necessary precautions to prevent electrical shock. Let's delve a little deeper into why these color codes are important and how they are applied in practice. Consider a scenario where an electrician is called to troubleshoot a wiring problem in a commercial building. The building has both 480 volts and 208 volts electrical systems. Without a clear understanding of the color codes, the electrician could easily misidentify the different wires, potentially leading to dangerous situations such as short circuits, equipment damage, or even electrical shock. By knowing that brown, orange, and yellow are typically used for 480 volts, 3-phase, and that black, red, and blue are typically used for 208 volts, 3-phase, the electrician can quickly and accurately identify the wires, saving time and minimizing the risk of errors. In addition to the phase conductors, the neutral and ground conductors also play critical roles in the safety and proper functioning of the electrical system. The neutral wire provides a return path for the current, allowing it to flow back to the source. It is typically connected to ground at the service entrance, creating a grounded system. This grounding helps to stabilize the voltage and provide a path for fault current to flow in the event of a short circuit. The ground wire provides a low impedance path for fault current to flow back to the source, helping to trip the circuit breaker or fuse and quickly disconnect the power. This protects people and equipment from electrical shock. It is essential that the neutral and ground wires are properly sized and connected to ensure that they can safely carry the fault current. The National Electrical Code, or NEC, provides detailed requirements for the sizing and installation of these conductors. The NEC is a widely adopted standard for safe electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements carefully. In addition to the NEC, many local jurisdictions have their own electrical codes that may be more stringent than the NEC. It is important to check with the local authorities to determine the specific requirements for electrical installations in a particular area. When working with electrical systems, it is always a good idea to follow a systematic approach. First, identify the voltage and phase of the system you are working on. Then use a voltage tester to verify that the circuit is energized. Next, identify the different conductors using the color codes and a voltage tester. Finally, perform the necessary work, taking care to follow all safety precautions. After completing the work, double-check all connections and verify that the system is functioning properly. In summary, understanding electrical color codes is essential for safe and efficient work on electrical systems. Always check local electrical codes for specific requirements and use a voltage tester to verify the wiring before working on any electrical system. Remember to prioritize safety and take all necessary precautions to prevent electrical shock. It's also worth noting that while color codes are helpful, they are not foolproof. Over time, wires can become faded or discolored, making it difficult to identify them based on color alone. Additionally, in some cases, the original wiring may have been done incorrectly, resulting in wires being misidentified. This is why it is so important to always use a voltage tester to verify the wiring before working on any electrical system, regardless of the color codes. Furthermore, the use of proper labeling is also crucial for maintaining a safe and organized electrical system. All circuit breakers and electrical panels should be clearly labeled to indicate the circuits they control. This makes it easier to identify the correct circuit when troubleshooting or performing maintenance. Labels should be durable and resistant to fading or damage. In addition to labeling, it is also important to keep accurate records of all electrical work that is performed. This includes documenting any changes or modifications to the wiring system, as well as any repairs or maintenance that is carried out. These records can be invaluable for future troubleshooting and maintenance. Another important aspect of electrical safety is the proper use of personal protective equipment, or PPE. When working with electrical systems, it is essential to wear appropriate PPE to protect yourself from electrical shock, burns, and other injuries. This includes safety glasses, insulated gloves, and arc-rated clothing. Safety glasses protect your eyes from flying debris and arc flash. Insulated gloves protect your hands from electrical shock. Arc-rated clothing protects your body from burns in the event of an arc flash. The specific type of PPE that is required will depend on the nature of the work being performed and the voltage of the system. It is important to consult with a qualified safety professional to determine the appropriate PPE for a given task. Regular inspections and maintenance are also essential for ensuring the safety of electrical systems. Electrical systems should be inspected regularly for signs of wear and tear, such as frayed wires, loose connections, and damaged equipment. Any problems that are identified should be repaired promptly. Maintenance should be performed on a regular schedule to prevent problems from developing in the first place. This includes tightening connections, cleaning equipment, and replacing worn parts. Finally, it is important to stay up to date on the latest electrical safety standards and practices. The electrical industry is constantly evolving, with new technologies and safety practices being developed all the time. By staying informed, you can ensure that you are using the safest and most effective methods for working with electrical systems. There are many resources available to help you stay up to date, including trade publications, industry conferences, and online training courses. In addition to the points already discussed, it's worth touching upon the specific requirements for grounding and bonding in electrical systems. Grounding refers to the connection of the electrical system to the earth. Bonding refers to the connection of different metallic parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for safety. Grounding helps to stabilize the voltage and provide a path for fault current to flow in the event of a short circuit. Bonding helps to ensure that all metallic parts of the electrical system are at the same potential, reducing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. These requirements cover a wide range of topics, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding different metallic parts. It is important to follow these requirements carefully to ensure the safety of the electrical system. Another important consideration is the selection of appropriate overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. They work by interrupting the circuit when the current exceeds a predetermined level. The NEC provides detailed requirements for the selection and installation of overcurrent protection devices. These requirements cover a wide range of factors, including the size of the conductors, the type of load, and the interrupting rating of the device. It is important to select overcurrent protection devices that are appropriate for the specific application to ensure that the circuit is properly protected. Furthermore, it is crucial to understand the concept of arc flash and arc blast. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical circuit. Arc flash can generate intense heat, pressure, and light, causing severe burns, injuries, and even death. An arc blast is the pressure wave that is created by an arc flash. The pressure wave can be strong enough to knock people off their feet and cause structural damage. To protect against arc flash and arc blast hazards, it is important to follow appropriate safety procedures and use appropriate PPE. This includes wearing arc-rated clothing, using insulated tools, and maintaining a safe working distance from energized equipment. Arc flash studies can be conducted to assess the potential hazards and determine the appropriate safety measures. In addition to the technical aspects of electrical safety, it is also important to cultivate the strong safety culture. A strong safety culture is one in which safety is a top priority and all employees are committed to following safe work practices. This includes providing adequate training, promoting open communication, and encouraging employees to report any safety concerns. By cultivating a strong safety culture, you can create a safer work environment for everyone. Finally, it is worth reiterating that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electrical systems, it is best to call a qualified electrician. Electricity can be a powerful force, and it is important to respect its potential hazards. By following appropriate safety procedures and using appropriate equipment, you can minimize the risk of electrical accidents and injuries. In conclusion, electrical color codes, voltage testers, PPE, grounding, bonding, overcurrent protection, arc flash safety, and a strong safety culture are all essential components of a safe electrical system. By understanding these concepts and following appropriate procedures, you can help to prevent electrical accidents and injuries.